Hello, welcome to Anybody Can Learn. Today we will solve a problem based on a decision tree. So let's consider the first problem. Given a data is, consider the following split in a decision tree algorithm. The algorithm terminate at this level. Therefore, L1 and L2 are the leaf nodes. So question 1 is our parent node, and if answer is yes, we will go to L1. Or if the answer is no, we will go to L2. L1 and L2 are the leaf nodes. The question is, what are the labels associated with L1 and L2? An option given to us are option A L1 label 0, option B L1 label 1, option C L2 label 0, and option D L2 label 1. And the information given to us is question 1 has a number of points 120 with label 0. Question 1 has number of points 100 and label 1. L1 has number of nodes, number of points 70 and label as 0. L1 has number of points 30 that's belong to label 1. L2 has number of points 50 belongs to class belong to label 0, and L2 has number of points 70 and label as 1. And they ask what are the labels associated with the node L1 and L2. Now understand the concept of leaf node. The question says the algorithm terminate at this level. That means we are not going to split L1 and L2 any further. A leaf node is the final node of the decision tree, and each leaf node gives the final prediction. So in our question, L1 will give the final prediction for the node L1 and L2 will give the final prediction for the node L2. And the classification rule is leaf label is equal to majority classes in that leaf. That means we will label the leaf node with the majority class in that leaf. The data given to us is that 70 points belong to class 0 in L1 and 30 points belong to class 1 in L1. So total number of points are 70 plus 30. That means L1 has total 100 points. In node L1, compare the classes of each point. So 70 is more than 30. So it clearly means that the class 0 has more data points. Therefore, majority class in L1 is class 0. So L1 belongs to class 0. So we will label the L1 as class 0. Now let's see the label for node 2. Label 2, node 2 has 50 points that belong to class 0, and also it has 70 points that belong to class 1. So total points in the node L2 are 50 plus 70. That means number of the total points in node L2 is 120 points. Now compare the points for each class. So 70 is greater than 50. So the class 1 has more data points. Therefore, we can label L2 as 1 because majority class in L2 is 1. So option D L2 is equal to 1 is correct. So our final answer is L1 label as 0 and L2 label as 1. Let us see another question based on a decision tree. Similarly, the question 1 is split into L1 and L2 node. If the answer is yes, we will go to L1, and if the answer is no, we will go to L2. And the algorithm terminate at this level. Therefore, L1 and L2 are leaf node. Now focus on node L1. In a binary classification tree, and inside the node L1, we have 40 data points that belongs to class 0 and 60 data points that belong to class 1. And the question is, what is the impurity of L1 if entropy is used? And report answer correct to 3 decimal places. Use log base 2 for all algorithms. So first upon, we will understand what the impurity means. Impurity means mixing of different classes is called as a impurity. In a decision tree, a node can contain data point from different classes. For example, let us consider the scenario that a 50 points of class 0 and a 30 points of class 1. So in this case, a node contain both the classes, class 0 and class 1. Therefore, it is impure. Now understand what do you mean by pure node and mixed node. A pure node means it has only one class. That means it is completely pure. For example, if a node contains 80 points of class 0 and 0 points of class 1, that means it has pure node. That means its impurity is 0. A mixed node means it has 40 points of class 0 and 40 points of class 1. So it has contain both the classes, class 0 and class 1. Therefore it is highly mixed, and therefore it is called mixed node, and its impurity is high. Now understand what do you mean by entropy. Entropy means measure of impurity or uncertainty. In a decision tree, impurity answers a specific question: how mixed are the classes inside a node? So if the classes are more mixed, then it has high entropy. And if the classes are more pure, then the node has lower entropy. So entropy means the measure of impurity. The formula for entropy is H of S is equal to minus P0 times log with a base 2 of P0 minus P1 times log with base 2 of P1. So P0 means probability of class 0, or also called as a proportion of class 0, and P1 means probability of class 1 or proportion of class 1, and we are calculating with logarithm of with base 2 because the question has mentioned calculate with logarithm with base 2. Now understand the data given to us. We have given 40 points with a class 0 and 60 points that are belong to class 1. So total number of points are 40 plus 60, that is 100. Now understand the probability formula. Probability or proportion is equal to number of specific class points divided by total number of points. So let us calculate the P0, that is proportion of class 0. So P0 is equal to number of specific class point. Number of specific class point means number of points belong to class 0. So it is a 40. 40 divided by total number of points. Total number of points is 100. So P0 is equal to 40 divided by 100. So it is P0 is 0.4. That means 40% belong to 0. 40% points belong to class 0. Now calculate the proportion of class 1. That is P1. P1 is a probability of class 1 or also called as a proportion of class 1. So number of points that belong to class P1, class 1 is 60. Therefore, it is a 60 divided by total number of points. Total number of points is 100. So it is a 60 divided by 100. So P1 is 0.6. This means 60% of points belong to class 1. Now calculate whether P0 plus P1 is 1 or not. So 0.4 plus 0.6 is 1. So it so we are calculation our calculation is correct. Now substitute the values into our formula of entropy. Entropy formula is minus P naught or P0 multiplied by log with base 2 of P0 minus P1 times log with the base 2 of P1. Just now we calculated P0 as 0.4 and P1 as 0.6, and logarithm of P0, that means logarithm with base 2 of 0.4 is approximately 1.321928, and log of log with base 2 of P1, that is 0.6, is approximately equal to minus 0.736966. So substitute this value. So entropy is equal to minus 0.4 times log with a base 2 of 0.4 minus 0.6 log with a base 2 of 0.6. After substitution, we have the formula h is equal to minus 0.4 times 1.321928 minus 0.6 times minus 0.736966. So after calculation, we know that 0.4 multiplied by 1.321928 is equal to 0.52877112, and 0.6 multiplied by 0.736966 is equal to 0.44219796. Please recall that minus sign multiplied by minus sign is equal to plus sign. So both the terms become positive. So add this term. So answer become h is equal to 0.52877112. First term is plus second term 0.44219796. So it become h is equal to 0.9709508. So we have told to round up to 3 decimal places. So our answer is 0.971. So what does the 0.971 means? For a binary classification problem, entropy lies between 0 and 1. That is, entropy is greater than or equal to 0 but less than equal to 1. Our answer is 0.971. This is quite close to 1. Therefore, node is fairly impure. This is because we know that 40% of points belong to class 0 and 60% of points belong to class 1. 0 impurity means the node has only one class, and if the entropy is 1, that means the 50% points belongs to class 1 and 50% points belong to class 0. This means highly mixed. Now let us understand the question number 6, which is also based on decision tree. And data given to us is that the parent node Q is split into two child nodes, L1 and L2. The classes are 0 and 1. The distribution of the data point is parent node has 120 points that belong to class 0 and 80 points that belong to class 1. Child node L1 has 70 points that belongs to class 0 and 30 points that belongs to class 1. Child node L2 has 50 points that belong to class 0 and 50 points that belong to class 1. And our goal is calculate the information gain obtained by splitting Q into L1 and L2. Use entropy as the impurity measure and use log with a base 2 for all logarithms. Report the answer correct to 3 decimal places. So understand what do you mean by the information gain. So information gain means we are asked how much does the split reduce the impurity, and that quantity is called the information gains. So information gain tell us how much impurity has been reduced. So I am repeating it again. Information gain tells us how much impurity has been reduced. Since the question says to use entropy, we use entropy as our impurity measure. So information gain is equal to parent entropy minus weighted child entropy. So this information gives us the impurity reduction from parent to children. And the formula for information gain is Ig is equal to entropy of the parent node minus total number of data points in L1 divided by capital N is total number of data points in parent node times entropy of the L node, L1 node plus number of data points in L2 divided by total number of data points in parent node times entropy of the child node L2. So the information gain equals the entropy of the parent node minus this all term is called as a weighted entropy of the child node. Look toward my cursor. I am moving here the cursor. This term means weighted entropy of the child node. Just now we understand the entropy measure means entropy measures the impurity or uncertainty in the node. And for binary classification problem, the formula for entropy is E of S is equal to minus P0 times log with a base 2 of P0 minus P1 times log with a base 2 of P1. And where P1 is the probability of the class 0 and P1 is the probability of class 1, and it is calculated by the formula P0 is equal to number of classes of 0 points divided by total points, and P1, that is probability of the class 1, is calculated by the formula number of classes 1 points divided by total number of points. And always remember that P0 plus P1 is equal to 1. So verify your fractions are correct. Now calculate the total points. So parent node contains 120 points that belong to class 0 and 80 points that belong to class 1. So total number of the points in a parent node is indicated by this capital N. So it is 120 plus 80, that is 200. So there are total 200 data points that are belong to parent node. That means 200 total points are present for the split. Now calculate the number of the points in a child node L1. The data given to us in equation is 70 points belong to class 0 and 30 points belong to class 1. So total number of points in L1 is equal to 70 plus 30. 70 plus 30 means 100. Similarly, calculate the total number of points in a child node L2. Data given to us in question is 50 points belong to class 0 and 50 points belong to class 1. So total number of points in L2 is 50 plus 50, that is 100. So now check whether L1 plus L2 are equal to the total number of points in parent node. So it is 100 plus 100 is equal to 200. So these agree with the parent node which has a 200 points. So our calculation is correct. Now calculate the parent entropy. And parent entropy is calculated by the formula E of parent node is equal to minus P0 times log with a base 2 of P0 minus P1 times log with a base 2 of P1. Just now we calculated the total number of data points in parent node is 200. That means 120 plus 80. So it is a 200. Total number of data points in parent is 200. Now calculate the P0. P0 is a probability of class 0 in parent node. So the total number of points that belongs to class 0 in parent node is 120. So it is a 120 divided by total number of points present in a parent node. So it is a 120 divided by 200. It is a 0.6. P1 is a probability of class P1. Number of points that belong to class 1 in a parent node is 80. So it is a 80 divided by total number of point. It is a 200. So 80 divided by 200 is 0.4. Now check 0.6 plus 0.4 is 1. So our calculations are correct. Now substitute this value in the entropy formula. So calculate the log with a base 2 as 0.6 is minus 0.736966 and log with a base 2 of 0.4 is minus 1.321928. So after substitution we have 0.6 minus 0.6 times minus 0.736966. So it is equal to 0.442180 and minus 0.4 times log with a base 2 of 0.4 is minus 1.321928. So it becomes 0.528771. So add these two terms. So 0.442180 plus 0.587718 is equal to 0.97095008. So entropy of the parent node is 0.971. So impurity before splitting is approximately 0.971. Now calculate the entropy for the child node 1. So total number of points in the L1 node is 70 plus 30. So it is 100. And the P0, that is probability of the class 0, is 70 divided by 100. 70 because 70 points belong to class 0 divided by total number of points in L1. So it is 70 divided by 100 is 0.3. P1 is probability of class 1. Probability of the class 1 is calculated by number of the points belong to class 1 in L2 divided by total number of points are in L2. So it is a 50 divided by 100. So it is a 30 divided by 100. So it is a 0.3. Now substitute these in our entropy formula. So it is a P0 is minus 0.7 log with a base 2 is 0.7 minus P1, that is 0.3 times log with a base 2 of 0.3. So after the calculation it comes to be the 0.360218 plus 0.521089. So after addition it is 0.8812916. So entropy of the L1 node is 0.881. Now calculate the entropy for child node L2. So L2 has 50 points with a class 0 and 50 points with a class 1. So total number of the points in L2 is 50 plus 50 is 100. P0, that is probability of class 0, is number of the points that belongs to class 0 divided by total number of points in L2. So it is a 50 divided by 100. It is 0.5. Now P1 is the probability of the class 1 is equal to number of the points that belongs to class 1 in L2 divided by total number of points in L2. So it is a 50 divided by 100. So it is a 0.5. Now substitute this value in our entropy formula. So our P0 is 0.5 times minus 0.5 times log with a base 2 of 0.5 minus log 0.5 times log with a base 2 of 0.5. After calculation log with a base 2 of 0.5 is minus 1. So minus 0.5 times minus 1 minus 0.5 times minus 1. So it is 0.5 plus 0.5. So entropy of the L2 is 1. This makes the sense because L2 is exactly 50% of the class 0 and 50% of class 1. Look at here, we have 50 data points that belong to class 0 and 50 data points belong to class 1. Therefore 50% belongs to class 0 and 50% class belong to 1. So this gives the maximum entropy for binary classification, that is 1. We know that the entropy ranges between 0 and 1. Now calculate the weighted child entropy. Weighted child entropy is these terms: size of L1 divided by n times entropy of L1 plus size of L2 divided by n uh, times entropy of the L2. So after we know that entropy of the parent is 0.970951 and total number of points in parent node is 200, and the L1, the entropy of the L1 is 0.881292, and the size of the or the total number of points in L1 is 100. Similarly, child node L2 has entropy 1 and the total number of points in L2 is 100. So substitute this in our formula. So 100 means total number of points in L1 is 100 divided by 200 is 0.5, and similarly the weight of L2 is number of the points in L2 is 100 divided total number of points in parent node is 200. So 100 divided by 200 is 0.5. So its L1 contain 50% of the data point and L2 contain 50% of the data points. So the weighted entropy is substitute 0.5 multiplied by entropy of the L1 0.881292, and the 0.5 multiplied by entropy of the L2 is 1. So it becomes 0.440646 plus 0.50000. After addition it becomes 0.940640. So weighted child entropy is 0.940640. Now calculate the information gain. Information gain is calculated by the formula entropy of the parent node minus weighted child entropy. We calculated entropy of the parent node as 0.970951 and entropy of the weighted child entropy is 0.940640. So information gain is equal to 0.970951 minus 0.940646. So it becomes 0.030305. So rounded to the three decimal places, so it becomes 0.030. So we successfully calculated the information gain. Thank you.